So good morning, class. Okay, so today we will start discussing roots of nonlinear. Okay, this is part 2. So it is open methods. Okay, so for open methods, we are going to discuss the fixed point iteration. Okay, the Newton-Raphson method and the second method. So this method is another way of solving for the roots of nonlinear equations. Okay, so last meeting. Okay, you have your first quiz kasama yung bisection method and the regular fallacy method. So this time we will going to have your other methods, other three methods. Ito yung open methods, okay? Sige, mabilis lang to. Okay, let's start. So for the first method, we have the fixed point iteration. Okay, so for the fixed point iteration, it is a method of successive substitution, or we call it as MOSS. Okay, so ang ginagawa dito, you have equation. So if the equation f of x equals to 0 is rearranged to a non-unique form. Okay, i-arrange natin yung f of x natin into x equals g of x. Okay, so then an iterative method may be devised as this one. Okay, so x of n plus 1 is equals to g of x of n. Okay, yung n natin is yung iteration number natin. So we have 0, 1, 2, 3, something. Okay. Note that yung g of x sub n is yung iteration function mo. Okay. And yung x n plus 1 equals g of x of n. Ito yung iteration scheme. Okay. So discuss natin kung paano yan. Okay. So ang idea dito is the fixed point iteration method is first to reformulate an equation to an equivalent fixed point problem. Okay? So kunwari, meron kang function na f of x. Ang gagawin mo, ko-convert mo yung function into x equals g of x. Okay? And you will use that function, this iteration scheme, to find the roots of the equations. Okay? So we are hoping that at x of n, okay, na magko-converge siya sa isang values, okay, alpha, which are the root. Okay, so imagine, let's have for example an equation na f of x equals x minus 1 minus 0.5 sine x. Okay, kung i-graph natin siya, we know that yung roots natin is 1.499. This one. Okay? Okay, so ginamitan ko siya ng plotting using Desmos. Okay? So, ang ginagawa ng fixed point iteration, di ba sabi nga, so may function ka, let's say you have your function, function natin, recall, a function natin is equals to x, 1 minus x, x minus 1, x minus 1. Okay. So, x minus 1, okay, minus 0.5 sine x. Okay. Wait lang class, hold lang kayo. Okay, hello? Naririnig na ako, class?
Yes po.
Okay. Sige. Di ba ang functions natin is x minus 1 minus 0.5 sine x. Okay. The goal is to create an iteration scheme such that yung function natin is x equals g of x. Magiging ganito siya, di ba? Okay. Okay, so we will equate the function into x equals g of x. So ang ginawa dito, okay, transpose lang sa kabila yung dalawang hindi x. So nangyari, we have x equals to 1 plus 0.5 sine x. So we are hoping that this iteration scheme will converge to a value. Okay. So, ang nangyari, kung consider mo yung graph ng dalawa, the intersection of that two graph, you have y equals x and you have y equals 1 plus 0.5 sine x. Okay, the intersection at that point is the solutions of the equation. Okay, so solving for that, getting the intersection, you have the 1.4987 roots. So almost equals to the root na dun sa buong function natin na 1.499. Okay, so for the solution, okay, we are going to use a numerical scheme called the fixed point iteration. So it amounts to making an initial guess of x sub 0. So we'll have your initial guess and substitute that into the right side of the equation. Okay, so the resulting value is denoted by x sub 1, and then the process is repeated until such time that the values is converged to a to a point. Okay, hindi na siya nagbabago, nagko-converge na yung values. Okay, so for the solution, okay, since we have the iteration scheme of this one, x equals 1 plus 0.5 sine x. So ang gagawin nyo lang class, substitute lang kayo ng ng values. Okay, so ang first guess natin, let's say x sub 0, okay, is equals to 0. Ayan. So, gagawin mo lang yung x sub 0 equals to 0. Then, next iteration, syempre, yung x sub plus 1, pasok mo lang yung value na lumabas doon. Okay? Then, ayan. Okay? Kasi kapag pinasok natin yung x sub 0 equals 0, pasok mo lang dito. Okay? Next naman is the value from 1 plus 0.5 sine 0, yun yung ilalagay mo dito. Ang value nito is, this is 1. Okay? Then after that, ito ipapasok mo doon ulit sa x sub 2 mo. So 1 plus 0.5 sine of x sub 1, you have 1 plus 0.5 sine of 1. Okay? After that, after getting the values here, pasok mo ulit dito sa next answer, 1 plus 0.5 sine of x2. Okay? Okay, pasok mo ulit dito, 1 plus 0.5. Okay? Until it converges. Okay, so for this one, ang answer dito is 1.4207. Okay, dito. Then isa-substitute mo siya dito. Then you get 1.49. Then also this one, you have your 1.498, etc. Hanggang sa mag-converge na yung value or pumasok na dun sa tolerance natin. Okay, so for our tolerance, let's say our tolerance, syempre, ito yung for acceptance tolerance, syempre ang gagawin mo kapag yung values ng x sub n plus 1 minus yung x sub n, okay, all over the absolute value is less than your tolerance, okay, you will accept your values, your roots. Okay, did you get it, class? Hello. Do you have any questions?
None po.
Ang problem lang dito, so we show that the result, after the first 10 iterations clearly converged to a value of 1.4897. Yan, this value. Okay, almost converging na siya kasi starting from 7, lagi na siya nag-497 4987011. Okay. So the problem is how to transform the original equation, okay, to an iteration scheme. So there are different possible choices, di ba? Maraming ibang way to transform the function into an iteration scheme of x equals g of x. Okay. So for example, this one. So we have the f function, f of x equals x squared minus 3 equals 0. Okay. So solving for x, convert natin siya into x equals g of x. Okay. So we have the first arrangement na x equals x squared plus x minus 3. Okay. Nag-plus x lang dito na nag-plus x sa labas. Okay. Also, we have x equals 3 over x. Okay? Kasi kapag pinasok mo yan doon, x squared minus 3, same lang siya ng x squared minus 3. Okay? So, and also, we have this one na x equals 1/2 x plus 3 of x. Kapag sinimplify mo to, you will converge. Pag sinimplify mo yung all a to c, you will get the function x squared minus 3. Okay? So this is the hard part. Kung paano mo malalaman yung arrangement ng iteration, fixed point iteration scheme. So ito yung pitfalls. Okay? So let's see kung ano ba yung tatlong possible cases na mangyari sa'yo during your iteration ng fixed point. Okay? So let's say we have your first initial guess of x sub 0 is equals to 2.0. Okay? Using the three cases, okay? The first case, this one, the x equals x squared plus x minus 3 is diverging. So ibig sabihin, going to infinity po yung values. So you will not be getting any possible answer for this one. Okay? For the case B, x equals 3 over x, it is oscillating. So ang ibig sabihin po, parang naka-sinusoidal function yung equation mo. Okay? Bumabalik-balik lang siya. 2, 1.5, 2, 1.5, 2, 1.5. Okay? So you will not converging to a value again. Okay? For the case C, ito, third case, this one is the right iteration scheme because the values is converging. So converging to siya into a number. Okay? So the proposed iterative schemes do not always converge with an arbitrary chosen from g of x. So this is the hard part in the fixed point iteration. Okay. So for getting that, if g of x or g prime of x are continuous on an interval about a root, okay, the equation, and if g prime of x is less than 1 for all x in the interval, then we assume or that the iteration scheme will converge to a root, okay, provided that x sub 0 is a chosen in the interval. Okay? So, kanyari, yung g prime of x mo daw, okay, is less than 1, okay, for all x in the interval, okay, then you will get the roots of that equation. So, yan yung theorem class. Okay? So for, saan ba yung ano natin? Okay, for this one, you have 1/2 x plus 3, okay, minus 3 over x squared. This, saan ba to? Okay, this one. Okay, you have, kapag kinuha natin yung g prime of x, we have 0.5 cosine x. Okay, so we have 0.5 cosine x. Cosine x. Okay? So 0.5 cosine x. So for yung first ano natin, syempre 0. Okay? So ang ginamit natin is yung 0, okay? First iteration, so 0.5 cosine of 0, you have 0.5. Okay? This is g prime of x. First example natin. So we have 0.5 cosine of 0, you have 0.5. So this is less than 1. Then we all know that yung point, yung g of x natin is will converge to a point. Okay? Sige. So ito yung mga possible cases. Kung yung g prime of x mo is greater than 1 in the interval, in your interval, okay, so it will diverge monotonically. Okay? So for your g prime of x mo is between 0 to 1, okay, it will converge. So ito yung kailangan natin. It will converge to a point. Okay? Oscillating naman siya kapag g prime of x is negative 1 to 0, and oscillating siya kapag, and diverging kapag less than negative 1. Okay? So this is yung solution para malaman mo kung yung ginawa mo bang function is converging to a value. Okay? Also, additional to this, di ba nakita nyo na nag-graph tayo ng points? Okay? We graph the two equation. We graph the x and the g of x. Okay? Kapag nag-intersect sila, class, okay? Ang ibig sabihin nun, you will have the point at you will have the root at that point. Kapag graph nyo at hindi sila tumugma, hindi nag-intersect, okay? Kahit anong gawin nyo, hindi kayo makakakuha na, hindi kayo mag-converge to a root. Okay? Nakuha ba yung class? Okay? So, other solution is you will graph the two iteration scheme. Pag nag-intersect is yan, makakakuha kayo ng roots. Okay? Any questions, class? Hello? Wala?
None po.
So far po.
None po.
Okay. So, next method, we have the Newton-Raphson Method. Okay. So, ito yung pinakagamit na method for finding the roots of the algebraic equation. So, fun fact, nung last time, wala nang shift solve na calculator, di ba? Hindi inalaw ni PRC yung paggamit ng mga shift solve na calculator. Okay? So, one problem in the board exam is how the takers will get the roots. Okay? So ang binigay sa mga ang mga pre-propose sa review center is yung Newton-Raphson method, okay, the iteration, yung incremental search, okay? So you can use the Newton-Raphson or the incremental search. So napakagamit na gamit talaga yung numerical methods during that time kasi nga pinagbawal ni PRC yung shift solve. So nag-cram yung mga takers. Okay? So I just want you to understand deeply lang itong numerical solutions in getting the roots. So kunwari, dumating yung time na magti-take na kayo ng board exam and pinagbawal na talaga yung paggamit ng calculator na may shift solve or hindi kayo matatakot, okay? You will get the roots of the equations. Okay. So for the Newton-Raphson method, it is the most widely used method for finding the roots of a nonlinear algebraic equations. Okay. It will locate the roots, okay, starting from initial estimate. So method is self-starting. Okay. So it can also be used to find a complex roots. Okay. For the Newton-Raphson method, we have this equation based on the slope of the tangent. Okay, x sub n plus 1 is equals to x sub n minus f of x sub n over f prime of x sub n. Okay, so this method is conceptually simple. Okay, kasi ito lang yung mga algorithm. Okay, so you will choose an initial guess of x. Okay, then find f of x. Okay, then locate that x and f of x on the curve and draw a tangent line. Okay, then find the intersection on the tangent line and the x-axis. Then this will be the new x values. Okay, repeat 1 to 4. Okay, and then ito yung na-derive na equation. Okay, sige, let's see. So another derivation is from the Taylor series expansion. Okay, the Taylor series expansion. Initial estimate of x sub 0 is given by this equation. Okay, and by truncating the above equation into only two terms, okay, it is now simplified as x sub n plus 1 is equals to x sub n minus f of x sub n over f prime of x sub n. Okay, so for the algorithm of the Newton-Raphson method, okay, you will guess x sub 0, your first point of iteration, okay, and compute for the f of x sub k and f prime of x sub k. Okay, kung yung f of x sub k is equals to 0 and f prime of x sub k is equals to 0, then you will stop and you will x sub k is the root, and kapag hindi, guess the new initial value. Okay. So kapag else, find your k plus 1 from this equation. Okay. And you will accept kapag yung tolerance is the absolute value for your k plus 1 minus x sub k over the k plus 1 is less than the tolerance, or your f of x sub k is less than tolerance. Okay, therefore your x sub k plus 1 is the root. Okay, then else kapag hindi pa rin, you will go back to step 2. Okay, you will get f of x sub k and f prime of x sub k. Okay, then the process repeat itself. Okay. So I note this method may either converge to a root or diverge if the starting guess is not close enough to the root. Okay, so kapag magko-converge daw siya sa root, or pwede siyang mag-diverge kapag sobrang layo ng initial guess mo. Okay, doon sa root mo sobrang layo, you will diverge to hindi siya pupunta doon. Okay, yung value mo. Okay. So let's try for an example problem. Okay. So using this Newton-Raphson method, okay, using x sub 0 equals to 0, okay, obtain the new Newton-Raphson. So iterates natin yung function to a given below. So ang function natin is 3x plus sine x minus e raised to x equals 0. Okay. So alam ko marunong pa kayo mag-derivative. So for the derivative of this one, you have 3 plus cosine x minus e raised to x. Okay? Ito yung derivative ng function. Okay? Derivative of sine x is cosine x. Derivative of e raised to x is e raised to x din. Okay, then copy the sign. Okay? So, ang function, ang iteration scheme natin is this one. X raised to k, xk pala, x sub k minus yung f of xk natin, this one. So, 3xk plus sine xk minus e raised to xk. Okay? All over yung natin, yung derivative. Okay? So, for the derivative, you have 3 plus cosine of xk minus e raised to xk. Okay? So, using an initial guess of x sub 0 equals 0, ito yung initial guess natin. Okay? So, you have this one. Okay? So, can you open your I think may calculator pala ako dito. Sige. Can you open your calculator? Sige, alam ko kaya nyo yung isolve. Yan. So, open ko rin ang calculator to. Ayan. Okay. Hindi yata nakikita. Ayan. Ito. For this one, okay, yung k sub 0 natin, then, syempre, isa-substitute natin yung f of x natin, this one. Okay, for getting the f of x, syempre, ilagay mo lang yung function mo. So, 3x plus sine x. Dapat naka-radian kayo, class, ha? Okay, so, radian minus e raised to x. You have, okay. So, calculate natin at x equals 0, you have negative 1. Okay. Then also, syempre, ilagay natin yung f prime of x natin na, okay, ilagay natin f prime of x natin, 3 plus cosine of x minus e raised to x, you have, okay, you have, calculate 0, you have 3, this one. Okay, so solving for the next iteration, okay, so you will check kapag yung f of x mo ba is 0, hindi pa po. So hindi pa pasok sa tolerance natin yan. Okay, so ang gagawin natin, use the Newton-Raphson method. Okay, so x, Okay? Minus, so yung x natin is 0, di ba? Minus the f of x, negative 1, all over 3. Okay? Yung f prime of x natin. So you have your x na 0.333 for your next iteration. Then do the process again. So find the f of x and f prime of x. Then solve. Okay. Then pasok na ba sa tolerance? Hindi pa. So use again the Newton-Raphson iteration. So after 5 iteration, almost 4 iterations or 5 iterations, you will arrive to an answer of 0.36042173. Okay? Sige. So, ito siya. Nandito siya sa 0.3. So, nandito yung graph. Okay. So, using your calculator, sinabi ko nga, dapat ito yung nasa una. Okay? Ganito lang gagawin yung class. So, x, di ba? Isulat nyo lang yung formula dun sa, sa calculator. So, x minus, okay, 3x plus sine x minus e raised to x. Okay. Then ilagay niyo yung function sa ilalim, yung derivative sa ilalim. Okay. 3 okay, plus cosine of x minus e raised to x. Okay. Nasusundan ba to, class? Ayan. So, ang gagawin nyo lang, class, is pinutin nyo yung solve. Okay. Then, ilagay nyo yung first iteration nyo. So, yung first guess natin sa iteration natin is 0. Diba? Okay. So, 1/3 yung lumabas. Tama, diba? Na first iteration natin, yung k equals 1 natin, naging 1/3 na, diba? Okay. So, ang gagawin nyo lang ulit, pinutin nyo ulit yung solve. Okay. Pag napindot nyo yung solve, pinutin nyo yung answer, yung ans. So ang ilalagay niyo na value of x, syempre yung nakaraang value yung nakaraang answer. Okay? So yung previous answer, yung ilalagay mo value of x. Then pindutin yung equals 0.36017 yung lumabas. Tama ba na ito rin yung lumabas dito sa third iteration natin? Okay? 0.360170174. Okay? Then solve nyo ulit. Pindutin nyo ulit yung solve. Then yung answer, yung previous answer. Okay? Then equals, you will arrive at the same na 0.36042168. Okay? So hindi pa nagko-converge kasi yung last value natin is 36017. Ito ay 3604. Okay? So solve mo ulit. Okay, solve. After solve, pinutin nyo ulit yung answer. Okay, you will arrive to 0.360421703. So the same for the fourth iteration. K equals to 4. Okay. Then check nyo ulit kung solve for answer. So at fifth iteration natin, okay, the same na yung lumabas. So kahit anong gawin nyo, dito na mag-converge yung value natin. So this is the root. Okay? Nakuha ba yung class? Using your 570 ES calculator. Okay. So for your for other calculator, you may use you will try to explore na lang yung command na yung may solving function. Yung maglalagay ka ng variable, then you will compute. Okay. So try nyo explore yun. So dapat ganito yung style. Yung ilalagay nyo yung function, yung equation ng Newton-Raphson. Okay. Then solve and ipapasok nyo lang yung previous answer. Okay. Sige. So for next one, we have the second method. Okay, for the second method, so the original implementation of the Newton-Raphson involves analytically determining the f prime of x Okay, but I argue that numerical approximation to f prime of x works well. Okay, so solving the major weakness of the Newton-Raphson method, evaluation of f prime of x, which is far more difficult and needs more arithmetic operation to calculate the f of x. Okay, so ang problem kasi sa Newton-Raphson method, kaya nag-introduce sila ng second method is si Newton-Raphson method, you will find your derivative. Okay, the derivative of the equation. So f prime of x. Okay. So kunwari, you are solving that numerically. Hindi, 'di ba? Hindi mo ilalagay yung derivative dun sa numerical sa program mo. So matatagalan ka sa paglalagay ng derivative doon. Okay? So nag-introduce sila ng second method whereas hindi na kailangan maghanapin pa yung derivative ng function. Okay? So to circumvent this problem, a slight variation is introduced. Okay? So yung f prime of x is the slope of a tangent line. Okay? Since it is a line, why not replace the tangent line with a line that passes through 2 points? Okay? So, kunwari, given to example natin, we all know, class, di ba? The derivative is change in y over change in x. Okay? Whereas in change in y natin is pwede natin gawin yung f of x sub n plus 1 minus yung dating function all over yung x of n plus 1 dating function minus x of n. Okay? Ayan. Siyempre, mas malaki to kaysa dito. So, x of n minus 1 minus x of n. Okay. So, ang gagawin mo, isa-substitute mo lang to dito sa f prime of x. Okay? So, pagka-substitute class, ganito yung mangyayari. Then, siyempre, you will have your x sub n minus f of x sub n all over f of x sub n minus 1 minus f of x sub n over x sub n minus 1 minus x sub n. Okay? Then, reciprocal no denominator, pupunta sa taas, syempre. So, we have the equation na this one. Okay? Na x sub n minus 1 minus x sub n multiplied by your f of x sub n all over the f of x sub n minus 1 minus f of x sub n. Okay? So ito yung equation for the second method. So na-derive siya from the Newton-Raphson method using a finite difference approximation or the derivative. Okay? So for a second method, graphically, okay, this one, you will choose any two values, x sub 0 and x sub 1. Okay, draw a line that passing through that point. Okay. So you'll draw a line that passing through that point. Okay. And passing through the point x sub 0 to comma f of x sub 0. Okay, x sub 0 comma f of x sub 0. Okay. And also draw a point from x sub 1 comma f of x sub 1. Ayan. So you will draw a line, this one. Okay. You will get the x-intercept, x sub 2. Okay. This one is your x-intercept. Siyempre, kapag nag-pass ko ng line dyan, this one is your x-intercept. Okay. Then draw a line again from x sub 1 to f of x sub 1. Draw a line again dito. Then for x sub 2 comma f of x sub 2, this one, then kukunin ulit yung draw ulit the line, then get the x-intercept, x sub 3. So ito na yung second estimate. Okay. Hanggang sa mag-arrive into values. Okay. So you will repeat until the error converges to to your tolerance. Okay. So nangyari, nagdodraw lang sila ng line that passing through the point. Then kinukuha yung mga x-intercept. Okay. So for the second method, given this formula, Okay? It will require two functions. So evaluate natin yung x sub n and x sub n minus 1 to proceed to the nth step. Okay? It performs only one function evaluation per iteration. Okay? So you will need two initial guess of the unknown. Okay? You will need two initial guess, but it is not a bracketing method. Ha? Okay. So for example, you have this one, a real root of the equation f of x is equals to x cubed minus x minus 1. Okay. The roots lies in the interval 1, 2. Okay. So we will perform the iteration of the second method. Okay. Given this equation, okay. Sabi sa Newton-Raphson, di ba? You will find your two values. Okay, you will get the two initial guess of the unknown. So why not gawin na lang natin yung interval natin, sila na yung two initial guess natin. Okay? So yung two interval, the 1 and 2, sila na yung first two initial guess. Okay, nakuha ba yung class? Sige. Ganito yung table na ginawa ko for clarity na pagsosolve natin. Okay? You will get x sub n minus 1, then table for f of x sub n minus 1. Okay? Create a table for x sub n, f of x sub n, x sub n plus 1, and yung f of x plus 1. Then yung tolerance natin. Okay? Sige. Ang gagawin dito class, syempre, lagyan natin yung x of n minus 1 and this one. And yung x of n minus 2, x of x sub n, this one. So ito yung two initial guess natin. Okay? These are two initial guess. Okay? Then after that, syempre, solve mo yung f of x sub n minus 1. So get your calculator, pasok lang natin yan. You have x cubed minus x cubed minus x minus 1, you have at x equals 1, you have negative 1, okay? And at x equals 2, you have positive 5, okay? Okay. Then solve for x of n plus 1. Ito, solve na natin to. X of n plus 1. So solving x of n plus 1, you have the equation x of n. Okay, so 2 minus yung n minus 1 natin, which is 1. Okay, 1 minus 2. Okay, comma f of x sub n, you have 5. Okay. Over f of x sub n minus 1, you have negative 1. Okay, negative 1 minus f of x sub n, you have 5. Okay, then you have 1.1667. Okay, so ito na yung x of n plus 1 natin. Okay. Sige. So after getting this one, syempre, pasok mo ulit yung f of n minus 1 to eh. Okay. So ang gagawin mo, ikakopy mo lang to. Siya na yung panibagong magiging x. So this is f of x of n plus 1. So x sub 2 siya, tama? Pasok mo yung n equals 1. So this is x sub 2. Okay. So x sub 2 nandito yon. Okay. This is x sub 2 since x sub n siya. So n equals 2, you have x sub 2. So ipapasok mo siya dito. Okay. I-copy mo yung value na yan. This one. Okay. Before going to that pala, you will check kapag within tolerance na ba yung f of x plus 1 natin. Okay. Ito. Within tolerance na ba to? So ang gagawin natin, syempre x cubed, okay, minus x minus 1. Solve for x equals yung 1.1667. 16667. Okay. So negative 0.57. Okay. So hindi pa. Okay. So not within tolerance pa. Okay. Then solve again for fill up the table again. Okay. So ang gagawin natin, syempre, kakopy mo yung value doon, and also this one, copy mo rin yung value dito. Yan. Okay. Then solving again for the roots. Okay. Solve mo ulit yung function x of n minus 1. Syempre, dito, you have x cubed, okay, minus x minus 1. You have calculate for n equals 2. Syempre, 5. Okay. And solve again for n equals 1.1667. Okay. Ito. Okay. So, gagawin mo lang, syempre, solve again for the x of n plus 1, given itong apat na values. Okay. So, 1.1667 minus yung n minus 1 mo, syempre ito, 2. 2 minus yung x sub n mo, which is 1.1667. Okay. Your f of x sub n, you have 0.5787. Okay, negative 0.5787. Okay. All over the x sub n minus 1 minus fx x sub n. X minus 1, 5. Minus yung f of x sub n, you have 0.5787. Okay. Sorry. Ano ba? Dalawa. Wait. 1667. Tatlong 67 nilagay ko. So, tatlong 67. You have 0.5787. Okay. 5 minus 0.5787. You have okay, so may discrepancy na lumabas. Okay, okay lang yan. Kasi hindi exact value nilagay ko. Okay. So, kung gusto niyo ilagay yung for your exact value, syempre pwede mong gawin to. 1.253. Okay. Then again, solve for the f of x plus 1. You will arrive for negative 0.28536. Okay. Then solve again for the equation. Kung acceptance, within accepting tolerance na ba siya? Okay. So, hindi pa. Okay. So, gagawin mo ulit, ibababa mo ulit yung values dito. Okay, dito. And also this one. Okay. Also, ganun ulit dito. Yan. And also this one. Then dito, ganun ulit. Dito. And then dito. Nakuha ba yung class? Okay. So, if you want, pwede natin open gawan ng gawan sa tawag dito sa Excel. Okay? Can you open your Excel? Okay. I can share you since we have time. Okay. Since we have time, I can show you how to create your own table in your Excel. Okay. Ayan. Hello class. Ayan. So gagawin nyo, create your table. Siyempre, ulitin ko lang to ha. So n, x of n minus 1. Okay. May access naman kayo ng Excel lahat class, di ba? Ayan.
Yes po.
Sige, since we have time, I can help you to create your second method formula. Okay, so x of n, gawin nyo lang din to. Okay, x of n plus 1. Okay, nakikita nyo ba to? Hindi na tina-type ko.
Kita po.
Okay, so tolerance. Okay, this one. Sige, lagay na natin yung tolerance dito. Yan. Okay. So, gagawin lang natin, syempre, yung assumption natin, gawa kayo assumption dito, you have 1, okay, and 2. So, x of 0, x of 1, okay. So, 1, 2, i-drop down nyo lang, okay, kung ilan yung gusto nyo, so, fill series. Okay. Sige. Then, if pinutin nyo yung equals, siya yung first guess mo, okay, so 1, okay. Then dito, pinutin nyo yung equals, then dun sa second guess nyo. Okay? Ayan. So for your f of x sub n minus 1, syempre, kung ano yung function nyo, x cubed minus x minus 1, so lalagay mo lang din dito. So x cubed, okay, cube minus x minus 1. Okay? So n 12 cube minus n 12 minus 1. Okay? Then also dito naman sa f of x sub n, syempre, press equal sign. Then x cube, so ito yung kung ano yung value dito, cube minus ito minus 1. Yan. Then using the formula, this one, syempre, equal sign, f of x, yung x sub n, okay, x sub n, minus, okay, parentheses, okay, open parentheses, type nyo lang yung equation. Okay. X of n minus 1, ito, minus x of n, this one, okay, close parentheses, multiplied by your f of x sub n, ito, which is this one, okay, all over, open parentheses, okay, f of x sub n minus 1, minus of x, f of x sub n. Okay, so you have 1.16667. Okay, then yung f of x plus 1, syempre kung ano yung value nung nandito, ilalagay mo lang dito. Okay, so dito, this one, syempre, ay hindi dapat to x sub n plus 1. This should be f of x sub n plus 1. X sub n plus 1. F of x. Dapat ito may sub ha. Baka malito kayo. X of x sub n plus 1. Yan. Yan. Baka gawin nyo may plus 1 eh. Yan. Okay, nakuha ba yung class? Dapat ito ay f of x sub n plus 1. Ito, kung ano to mismo. Okay. So, lagay nyo lang natin. Equal sign, syempre, x cube, kung ano yung function natin. X cube minus yung x minus 1. You have this one. Okay. X cube minus x. Okay. X cube. Nakalimutan ko x cube. Yan. Okay. So for your accepting tolerance, syempre ang gagawin mo ganito. Equal sign, okay, if else. So syempre lagay ka lang if, okay, open parentheses, then yung logical test natin. Okay. So for the logical test natin, we all know that if the absolute value of the f of x sub n plus 1 is less than the tolerance, we will accept. Okay? So, ang gagawin mo ganito, if the logical test, syempre, the absolute value ng number absolute value ng ito, okay? Okay, close parenthesis is less than the tolerance. Ito yung tolerance natin. Okay, then comma. So what is the value if true? So kapag true, ang lalagay nyo, open parenthesis, accept. Okay, then close parenthesis, comma, what is the value of false? Di ba may lumalabas dito, value if false. So kapag value if false yung logical test mo, ilalagay mo, not within tolerance. Kayong bahala. So open parenthesis, not within tolerance. Okay, then close parenthesis, you have this one. Okay, not, ayan. Nakuha ba yung class?
Opo.
Sige.
Opo.
So pag may kulay lang, ang ginagawa ko lang dito, syempre, gantuhan mo lang. May ka ng conditional formatting, okay, highlight cells that contains, okay. So ang nakalagay ko sa akin, di ba, not. So kapag not, light, yung not within tolerance or not lang. Then highlight ko agad, conditional formatting, text that contains, accept. Kapag may accept, baguhin ko color green, okay? Green light with dark green text. Green field with dark green text. Okay. So ang gagawin lang natin is i-copy lang natin yung function sa yung mga ginawa natin formula pababa. Okay. Ano ba yung mauulit na mauulit sa cell? Okay. Siyempre, that second iteration, yung ginawa natin dito kanina, this one, kinakopy siya, di ba? So kung ano yung value nung nandun, ilalagay ko dito. Okay. So gagantiin ko lang equal sign, last previous value. Okay. Also dito, equal sign yung previous value. Okay. Then, drag down ko lang yung mga function dito. Okay. Drag down ko lang yung functions dito. Sorry. Okay. Ayan. So, kapag na-drop down ko kasi yan class, kung ano yung nasa row, yun yung ginagaya niya. Kunwari ito, N12, okay, nasa cell N12. Kapag drop down ko siya, nasa cell N13 siya. Dito, cell N14 yung nasa formula, N15, N16, and so on and so on. Okay? So kapag nandito, P12, nasa P12, pag drop down ko to, syempre, P13 to. Okay? Kung magkano kalaki yung ano nila, yung space nila, ganun din yung ikakopy niya. Okay? So kapag drop down ko to lahat, okay, kung ano yung values dito, ito yung kakopy. Kung ano yung value dito, nandun yung kakopy. Okay. Kung ano yung value dito, dito yung kakopy. So, ito-drop down ko rin to. Okay. Then, ito-drop down ko rin to. Ayan. Then, i-drop down ko rin to for this one. And i-drop down ko rin to for the logical test. Ayan. Okay. Okay, 0.037 for sorry. This one, syempre dapat ito ay naka dollar. Okay, kapag naka dollar sign, hindi mababago yung kung ano yung cell na yon. So kapag dinollar ko to, press nyo lang yung F4. Okay. Binago ko lang yung formula dito, press mo lang yung F4, then enter. Pag drop down ko siya, always yung N5 yung value dito sa less than tolerance. Okay, hindi na babago. Ayan. So, tingnan nyo sa class. After 5 iteration, after 5 iteration, accept na yung value. Okay? Pagdating dito sa 8 and 9, almost 0 na yung answer. Okay? Times 10 raised to negative 13, siyempre siguro nasa 16 and 20 na to. Okay? Nakuha ba yung class?
Yes po.
Sige. Balik tayo dito sa ating ayan. So, ganyan yung pag-solve for the second method. Okay? So, if we look on the graph, yung x cubed minus x minus 1 is nasa point ng 1.325. Okay? So, almost doon sa ating answer na 1.3247. This one. Yan. Okay? So, for the second method, computation, mas efficient siya compared to the Newton-Raphson method. Okay? Second method may diverge if initial guess are not well selected. Okay? Siyempre, kapag mas malayo, ganun din yung problema niya when compared to the Newton-Raphson. Since doon din siya na-derive, kapag yung root mo is malayo dun sa, yung initial guess mo is malayo, hindi almost diverging yung answer mo. So halos hindi ka mag-a-arrive dun sa roots. So ang suggestion ko, syempre, i-graph nyo muna yung function. So you will grasp kung ano yung nasan yung roots, okay? Then after that, syempre, mag-guess ka dun sa malapit. So this one, let's say 1, okay? Dun ka mag-start. So ganun din so during your kahit sa machine problem nyo or your exam, yun, syempre, i-graph nyo muna para malaman nyo kung nasaan yung roots. Then, dun kayo mag-start ng initial guess. Okay? Then, for the second method is the variation of the Newton-Raphson method. Since yung second method is na-derive lang sa Newton-Raphson method. Okay? So, last is the Newton-Raphson method requires a fewer iterations to obtain the desired accuracy than the second method. But the latter, the second method, needs only one function evaluation per iteration, okay, compared to the 2 iterations in the Newton-Raphson method. Okay, kasi the Newton-Raphson method needs 2 functions. You have the function itself, yung desired yung desired non-linear equation mo, yung f of x, and kailangan niya ng derivative function, kung ano yung derivative ng f of x. So, sa Newton-Raphson needs 2 iterations or new 2 evaluation function. Whereas yung second method naman, okay, for the second method, you need 2 initial guess, x sub 0 and x sub 1, but uses only f of x. Okay? So that's the difference between the second method and the Newton-Raphson method. Okay. Any questions, class? Okay. I leave you an hour for review for this one. See, kasi I will be giving your second quiz. Kasi kulang tayo ng time dahil I've been advised na next week is prelim exam nyo na. Tama ba, class? Aware ba kayo doon?
Opo.
Oo. So, kailangan ko pa ng isa yung quiz. So, bitin tayo sa oras kasi hindi kasi ako nakapag-meeting sa inyo ng first meeting. So, gagawin ko, I will upload your second exam, second quiz this afternoon, 6 p.m. And you will upload it. Take home na lang gagawin ko. So, upload nyo siya tomorrow at 12 noon. Okay? Nakuha ba yung class? So, bibigyan ko kayo ng second quiz 6 p.m. Upload ko na siya 6 p.m. And you will, papasa nyo siya 12 a.m. bukas. Hanggang 12 a.m. bukas. Okay. Is that okay for the class? May tutol ba?
Naman po.
Okay. So, ang coverage lang naman nun is ito, yung open methods. Okay. So, I leave you an hour to find an example, to find the sample problem. Okay? Para sa exam nyo mamaya. Okay. Sige. Do you have any questions?
Wala
None.
naman.
Sige. Okay, I will leave the meeting na.
Bye po.